Okay, this problem is an example of a time when you would just use your molar heat of vaporization because all I'm trying to do is evaporate water. That means we're just changing from water to steam, so all we need is that heat of vaporization. The first thing that I need to figure out is when I raise this liquid from 75 degrees Celsius to 100 degrees Celsius, and if you're asking where I got the 100 from, that's the boiling point of water. When I increase the temperature from 75 degrees Celsius to 100 degrees Celsius, how much energy is that going to take? So in order to figure that out, I'm going to start with my Q equals MCAT equation. My Q is the thing that I'm trying to find. My mass is given to me. It's 18.2 grams. My specific heat of water is 4.184. My delta T is going to be, I should have made this a delta. My delta T is going to be the difference between 75 and 100 degrees Celsius, which is 25. So I did final minus initial over here. I'll go ahead and plug this into my calculator. The thing that you need to pay attention to when it comes to these is units. So I got 1,903.72. That's in joules. What I need to get to in order to plug it into my heat of vaporization problem is kilojoules. So to convert this to kilojoules, I'm just going to say I have 1,000 joules in 1 kilojoule. And if you're lost on this, this goes all the way back to King Henry. So if you need a video on that, I'll add it in. So this would be 19.03 kilojoules. Okay. Now that I have that part done, I need to go ahead and solve my heat of vaporization problem. So the equation for this is delta H equals my delta H of vaporization times the mass divided by the molar mass. So my delta H of vaporization for water is 6.01. You need to memorize that number if you don't know it. The mass of water that's given to me is 18.2 grams. My molar mass is 18, and molar mass of water, I got that from the periodic table. I added 2 hydrogens to 1 oxygen. So this gives me the delta H for turning all of that into steam. So this first equation is how much energy I need to raise the temperature within the same state. So this is within the same state. And this is how much energy I need to finally break those intermolecular forces and turn this into steam. So I'm going to put this in my calculator. My answer for this is 6.077, and the units for this are kilojoules. So when I add these kilojoules to these kilojoules, I get 25.107 kilojoules. To adjust for sig figs, we don't use temperature for sig figs, so I'm going to look at this mass, and it's 3, so that means that it's really going to be 25.1 kilojoules for my final answer. So just to review what happened here, I raised the temperature of the liquid to 100 degrees Celsius to the level that it needed to be at in order to boil. And then after that, I had to break the intermolecular forces, which is why we use delta heat of vaporization for this. So I use my delta heat of vaporization equation to break the intermolecular forces and changes it to steam. So this heats up the water. This changes water to steam. So it's all one big process to answer the question, how much energy is required to evaporate that much water? If you have questions about this, let me know.